Here we go. About 45 seconds. Nice leisurely roll. Okay, John's mic'd up.
Hello.
30 seconds. Right there is good. And then you move around and I'll move with you. Okay. Got 5 seconds and then when they change, 1, 2, 3, 2. Wait a second until he switches.
Good morning, and welcome to Covestro. As part of Remake Learning Days, we'd like to introduce you to Covestro here at our North American headquarters. Quick reminder, any schools or students who want to earn a Career Ready PA Backpack Challenge badge or sticker should go at the end of the tour to the website and complete the survey. Before we actually go into the lab, I want to explain a little bit about Covestro and what we do. Covestro is a leading supplier globally of polymeric materials, products that may go into foams for mattresses and cushions, insulations, plastics that are used for LED housings, and raw materials that become coatings and adhesives. Today, we're going to be taking a look at the coatings laboratory facilities here in Pittsburgh headquarters. When you look at coatings, we sell the raw materials to companies that make the paint. This is usually high-end paint, things that go onto maybe your car or onto a bridge or a water tower, products that we want to last for years and years and years and have great strength and appearance. Here in the laboratory, we run tests day to day in a very controlled and repeated manner that mimic the situations that a paint will see in the real world. That, of course, is different for a bridge, or a car, or a wooden floor. So we have to have different chemists and different testing that takes place. One of the aspects of what makes a good coating is the resins, and that's our business. Here at Covestro, we make a wide range of coatings for raw materials, primarily polyurethane-based chemistry. These can be waterborne, solvent-borne, or solvent-free. We take those materials and we will produce coating formulations to try to show what improvements we can make to make you see in the real world even better than they are today. Here's our first coatings laboratory.
Good.
Here we are in our first coatings laboratory. You can see there's a wide range of test equipment around me here. And that, again, reflects the different kinds of testing we have to do on our paints. I mentioned that the first part of a paint formulation is the resin, the stuff that holds all of the other ingredients together. Here to talk about Covestro resins, and one way that we test them is our chemist, Stephanie Kane.
Thanks, John. So I actually have a couple Covestro resins here, and they vary in how they're incorporated into the final formulation. Now, we might choose one or the other based on our customers' needs, and a main customer need or innovation driver here at Covestro revolves around sustainability. Now, what that might look like here at Covestro is we might make modifications to the formulation in order to improve air quality by lowering organic solvents or VOCs or volatile organic compounds. We might increase the usage of bio-based materials. We might also improve curing conditions so we can ultimately lower energy costs. Now, taking a step back, there are actually several different types of chemistries that Covestro has across their portfolio. And John actually mentioned a few. So we have solvent-borne, we have waterborne, one component, two components. Now, because these range widely in their use and how the formulation behaves, the knobs that we might choose or turn in order to drive those sustainability targets or meet our customers' needs also varies across the board. Now, in order to make sure that we're making consistent quality products, which is actually my job here, we actually do tests on several batches or every batch of material, but we do several tests such as pH, viscosity, solid, color, just to name a few. Now today we are actually testing viscosity, and I'll demonstrate that. Now at Covestro we have several different types of viscometers that we might choose one or the other based on the viscosity or thickness of the material. Now this particular viscometer is used to measure waterborne or very thin materials as well. So what we're going to do here is, you can see I have some product. Now this is a waterborne dispersion. I'm going to take this spindle. Now I'm going to put it in the material, being careful to make sure that I am not incorporating any air bubbles. What that might do is that might throw off our measurement. Now, once I get the spindle on, what I'm then going to do is I'm going to make sure that it's submerged. And then I'm going to turn this viscometer on. Now, you can see that I have it set at a certain RPM or revolutions per minute. And based on that set RPM and the rotation of the spindle is actually quite sensitive. So what actually ultimately happens is there's an amount of torque that is placed on that spindle. And based on the set revolutions per minute and the torque experienced by the spindle, we're actually able to gather an average viscosity of the material. This might seem like a pretty simple test method, but it's pretty crucial in making sure that our products are within specification and also are actually stable over time. So thank you for letting me to show you just one simple test method and give you a very quick description or brief summary on our products. But I'm sure John will lead you through the rest of our testing. Back to you, John.
Thank you, Stephanie. Resins are our business. They're very important part of any paint formulation. And testing something like viscosity is critical. High viscosity liquid is tough to pour or to pump if you're trying to make or to apply it. But the resin is only one part of the formulation. To really understand what our resins do for paint. Here in the laboratories, we have to make paint to see how it looks and how it performs. To show
and I am this over here in Covestro, and so my job is to take the resins that Stephanie provides and make it into actual paint, because we want to test to make sure that our resins can actually work well within our paint. And so there are four main basic things for paint. There's the resin, which is the thing that we sell, of course, and it reacts to make a formulated paint for the application, right? So that's the chemical reaction that occurs. There's also additives, which can do a lot of things with like dispersing different pigments, or breaking bubbles within the coating because we don't want that, or stabilizing or protecting from the sun. And there's a multitude of other additives that can work as well. But there are also solvents, which are liquid products that allow us to apply the paint very nicely. So we want to, either roll it onto a floor or spray it across a car. We have to use solvents sometimes to lower the viscosity of the resin to make sure that it flows well. And then it will evaporate and then dry. And then the last thing is pigments. And so these are solid particles that give us the color of the overall coating. So if you want a white or a black or a yellow paint, you have to use certain pigments in order to get those colors. And so the interesting thing that I'll be talking about today is something called a pigment grind. So right here in this hood, I have a can of resin, right? And so you can see it's clear. So we're going to add some white pigment into it, and you can see that these are white powdered particles. And so in order for me to get it into the resin, I have to use something called a pigment grind. And so this is basically a special mixing process between the two pigments, and it has this blade that has teeth on it. Okay. My apologies. There's a blade with teeth on it, and it allows us to take all of the pigment particles and bump them across each other and hit against the walls of the paint can so that we can get smaller and smaller particles within the paint. So what I'll do is I'll lock this can into place and then put the mixer in. And then I will turn on the mixer. So I'm going to let it mix for a little bit so that the resin within the can will be all mixed together. Now I will start adding the powder slowly. And make sure it's all in there. And so now what it's doing is it's mixing around and it's going around within the can, and it is bumping all the pigment particles against each other so that it becomes smaller and smaller so that we can have a nice particle size for our coating. And the reason why this is important is because we really want, when we spray these applications, we want to make sure that everything is uniform when it sprays out, but also to make sure that it's not clogging up the tip of our gun because we're making very small particles when we spray. And so, we typically let this on for a little bit, and we have to make sure that the particle size is small enough. So to figure out if the pigment particle sizes are small enough, we have to do something called a Hegman test. And so what I have over here is the Hegman test, and it's a special piece of equipment where basically there's this path right here in the middle, and what you do is you take the paint that you want to test the particle size on, and you draw it down along this path. And as the path goes lower, the gap between the path and this blade here gets smaller and smaller and smaller. And as you have smaller particle sizes and the gap becomes smaller, you'll be able to see where the particles kind of end up on the size, and you can use that to gauge how small your pigments are. And so I have a formulated paint over here, and I'm going to just quickly demonstrate very briefly on how to run this test. So I'll apply the paint right there, and then I will take this blade, and then I will draw it down along here. And then here I will visually inspect, if there are any particles that I can see within, depending on what the size is. And right now, it's very hard to see on this camera, but there's actually no particles showing up here. So it's actually, we have a very small particle size that is suitable for spraying. So that is how we make paint, or one of the ways we make paint. And John will again talk about how we apply this paint.
Thank you, Daniel. So, once again, took a look at resins, and Stephanie showed us how scientifically we measure consistently how well those resins flow, because it makes a big difference in when you're making paint. Daniel showed us how we drive pigments in, because pigments are an important part of the paint. And you saw we have test methods to make sure that those particles of pigment are distributed nicely, evenly throughout the paint so that it does the best job that it can. The next step for most of our coatings is how they're applied to a surface. And most of the industrial coatings are actually sprayed. That becomes the next important step in our testing here at Covestro. We're going to relocate to another part of our building here where we have the spray application test center. While we do that, we'd like you to take a look at a video that highlights some of the applications where paints based on coatings, raw materials from Covestro are used. now we're at the spray application testing area. I'd like to introduce you to the technical manager, Scott Grace, and our spray expert, Corey Clemens. They're going to talk about spray application and how that important aspect of a coating is tested your equipment. Sorry, little tough with the microphone.
Thanks a lot, John. Welcome, everybody. This is a special portion of our laboratory here in Pittsburgh, which we call our Application Technology Center. So back in this area, we do the application of paint essentially by a variety of different methods. Maybe it might be brush and roll like you might be used to at your home, in your room at home. But as John mentioned earlier, a lot of how our industrial coatings are applied is via a spray application process. So I'm here with my colleague, Roy Clemens, and we're going to be demonstrating how we mix some of the paint as well as how we apply the paint. So what you can see here, the paint we'll be applying today will be what's called a two-component polyurethane paint. So the container that is at the bottom, the larger container, already contains a portion which we call part A, or sometimes the polyol component. So there's certain chemical reactive groups in that. And then what Roy's pouring in there is what's called the second component, or part B. And that has a different type of chemical functional groups in it, called polyisocyanate groups, which when they react together, both parts together, they will form what's called a polyurethane linkage, or that's a polyurethane coating. So this type of coating is actually an automotive coating. It's actually an automotive clear coat. So most cars are painted with 4 layers of paint, and the very top layer of the paint is what's called a clear coat. And that clear coat provides obviously very nice appearance to the coating, very nice high gloss, very nice smoothness and everything. But it also provides a lot of really good durability properties as well. So it also provides resistance to weathering, sunlight, provides resistance against scratching, like that. So, Roy already measured the paint. It's very important that we measure the paint in the right amount, so we have the right amount of these functional groups reacting together with one another. It's also very important.
Yep. It's also very important that we also mix the coating properly. So Roy's already done the mixing, and I think we're going to flip in to see what he's actually doing inside the booth. And this is a special booth that we have here. It's what's called a downdraft spray booth. This is very typical of what would be in an automotive refinish repair shop. So if you end up having your car wrecked and you have to have your car repainted, this is a type of booth. So we can actually bring a car into this booth. The part that Roy is spraying is what's called a speed shape. So it's a kind of a 3-dimensional object that has, you can see it has a lot of curvature. It kind of resembles the appearance of a vehicle, a car, but that particular shape allows us to be able to spray that onto the spray the coating onto that shape and be able to see how well it flows and levels on the various contours of that part. So you can see Roy is being very meticulous. You can also notice that Roy is wearing what we call PPE, or personal protective equipment. So you can see he has a spray suit on, which protects his skin and also his clothing from any of the paint. You can see he's wearing gloves to protect his hands. And you can also see he's wearing what's called a powered air purifying respirator. So on his belt in the back, it's kind of maybe a little hard to see, but on his belt there's a filter system, and there's a mechanized fan system in there, which basically pulls air from the environment, filters it properly, and then supplies it up to that shield that you see there. So this is a very nice, comfortable way to be able to spray. So Roy just finished the spraying. So then the next step of the process would then be to allow the coating to then dry or to cure properly. We call the process curing, which is where those reactive groups from part A and part B react together, and they form those linkages. So as you can see here, we have a part here that has been sprayed earlier. Maybe so. Are you seeing this? Yeah. So this is a part that we sprayed earlier, and you can see here this is showing that it has very nice smoothness, very high gloss, very nice. We call distinctness of image as well too. So it also provides very good hardness properties and very good chemical resistance properties for things such as acid rain in the environment, or some kind of cleaning agents you might be using for cleaning your vehicle as well. So again, this is kind of what the finished part would look like. So obviously, application is very important to the overall to the overall process of developing a paint. So we're now going to transition up to another area of our labs, up to our weathering laboratory. So pass it back to John.
Thanks, Scott, and thanks, Roy. You heard a couple of times Scott mentioned that spraying a paint well is really critical to good appearance on top of the formulation and the materials that are going into it. Next to thing that we're going to test, and next thing that's very, very important is, does that good appearance last long, particularly if a paint is outside and exposed to sunlight and rain? How long does it weather? So we're going to go over to our accelerated weathering lab, and while we move back over, we'd like to show you another video talking a little bit about the changes and trends that are driving innovation at Covestro.
Of this, there's actually a high intensity, which again simulates the wavelengths that would be in natural sunlight. So this basically, the rack will actually rotate around that light source. This machine also has the ability to be able to spray water and also adjust temperature. So it's able to simulate, weathering cycles for coating. This is the first type. Again, this is called a weatherometer. Come over with me this way. We have another type of device here also, which is called a QUV. So look at the QUV here as well. Okay, so this device here is a second type of exposure chamber that we have. It's called a QUV. You can see inside it here, there's also racks that hold panels as well. These ones don't rotate, they just stay fixed, but you can see the lights that we have inside of here. This will be a different type, a little bit different wavelength of light. for the for the exposure to the high intensity light. So we can utilize these chambers to be able to expose panels to see how well they weather. So typically, whenever we have panels, we'll typically make the panels like Roy did in the back a few minutes ago. We'll spray the panels back in the back, and then we have the ability to submit those panels to our testing lab here. Here's one of my colleagues in Parkwood, and Tim actually runs this weathering lab. This is this. So on the overall weatherability of the coatings as well. So we're able to do it in this room with this accelerated equipment in a matter of weeks or months, something that would normally take years out in the real world. So it really helps us as we develop new products. We can have results a lot quicker, so we know whether things were changing or having positive or negative effects on performance. So but of course, West flexibility. So let's move back to Daniel.
Fun time on your tour. So as Scott had mentioned, so we test for weatherability, but we also test for a lot of other things. Test for how fast the cable tours, what it looks like, if it's shiny or glossy. We also test for a lot of things like hardness or flexibility. And so I have two tests here that I will be demonstrating to show how flexible our coatings are. Basically, what it means is how durable those are going to withstand bending or any kind of thing that might hit the coating. So this is something called a conical transfer bend. And so I have two containers here that were sprayed and applied. So the first one here on the left, on my left, is flexible coating, and this other one is a brittle coating. So how this natural bend works is take this panel here and then put it within the slots. I'm going to lock it in so that's in place. So I'm going to take this bar and just quickly bend it over the cone. Sometimes it gets stuck, but problem. Well, so sometimes it gets stuck, but thankfully I have backup panels over here.
Me. Still be good, Dan. Go ahead.
Okay. So,
Yeah, this is.
right, so this is the brittle coating, right? And so it cracks right here on this small bed. And that means that this coating is a lot harder than this one. You know, sometimes you want flexibility, sometimes you want harder coating. So,
Can somebody mute Ben's phone?
whether or not. Now, I just think that's over here. But, so what basically there's the over down your facing it.
No, we have really bad audio. Yeah, there's no audio at all.
Just John's phone, it looks like.
All right. So you notice that I kept track of how high I lift up that weight because it's very dependent on you know, what type of force they'll be. So again, I have two panels, right? So this panel is the flexible one. You can see, you know, with that indent right there, there's no package or nothing. So it's very flexible coating. Once again, and this one's the brittle coating, and you can see it cracked right around this edge here. And so again, this is just another test, you know, for our customers to say, you know, this one might be more flexible and this one might be more harder. It's kind of up to you to decide what. So that's some of the testing methods that we have. There are many more, but we don't have this. So thank you for joining in.
Thanks again, Daniel. You can see, again, there are so many different test methods that we use here in the laboratory. The impact and flexibility test, the data, that is a mimic for what might happen in a car accident, real world, when you dent your door. Does the paint stay on, or does it chip off? Scott and Tim showed us the accelerated weathering. That gives us an idea of whether a coating we're testing here in the laboratory will last for 20 years on a bridge. So we only have to paint it every so often. We also have different series of paint tests that are used for floor coatings, garage coatings, anything that might, any place that the coatings may be used. One last ingredient, what we do here at Covestro, beyond the ingredients and the test equipment and all of that, is our, wanted to show you one last video. And it's going to talk about some of the different people, the wonderful scientists and colleagues that we have here at Covestro, trying to come up with sustainable advances and make your world a brighter place.
So, thank you again for joining us on the tour of our coatings laboratory facilities here in Pittsburgh. We're back in the spray area and have all of the people that participated on our tour here today. And we'd be glad to take on a couple of questions if you would like to enter any questions from the audience. If there's anything about Covestro, our laboratory, the testing, or being a scientist that you might be curious about. Hello back to our colleague saying hello from Korea. Always nice to know when you're in a global company that you have colleagues around the world who are, people that you get to know and people that are on the same wavelength and people doing the same kind of innovation. Okay, I see that we have one question as to what would be the carbon footprint impact of using ultra white paint for coating buildings. Usually that's an issue for the roof, and it's always a question as to where is the roof, because if you're in a hot environment, the reflective coating on the roof will help to keep that building cool. But then again, if you're in a cold place, you might want some of that heat in passing through the building. But anytime that you can have an application where you can reduce the amount of energy needed for heating or cooling, that is an improvement that will affect the overall environmental impact and CO2 footprint. Oh, I'm sorry, we couldn't see that one.
Anyone help enrich information on Covestro's resins range? There you go. Resins range for auto finishes, complementing this.
This is one, I'll throw this one over to my colleague Scott.
Yeah. Hi, everybody. Thanks for the question. Certainly the use of nanotechnology is something that we often look at in some of our global laboratories. Often a lot of that work happens at our headquarters laboratories over in Germany. But certainly, types of things like different nano additives and things like that can have some positive effects on properties like scratch resistance, for instance, which is very important for automotive coatings. It's always important to try to improve the clear coat technology that's used in either automotive OEM or automotive refinish systems, so that they can better resist scratching to things like things like car washes or just people brushing up against the car, things like that. So we're always looking for ways to improve the scratch resistance. There's things we can do with the resins that have a very nice positive impact on scratch performance. There's also some things with things like nanotechnology, which can also move us in the right direction as well.
Thanks, Scott. Yes, we have a question. Very good question. What skills are needed for students to pick up to be able to work at Covestro? Well, there's a couple layers of answers there. We have a wide range of jobs here. Not everybody is technical laboratory people. We have people who are salespeople. We have people who are in product management, who are in logistics, making sure things get delivered. But more specifically, if you are interested in innovation, you have to have a basic good skill set in basic science and in mathematics. Those come into play pretty much every day for us here in the lab. Many of us have studied chemistry at a university level. Not all of us. You have people who have come into our laboratories out of a technician program where they have really just focused on what it takes to be a good and effective laboratory technician. So there are a lot of good paths to get in. Some of the most important skills are ones that you have to start learning way back in middle school and high school. Teamwork, the ability to work together and to communicate effectively are absolutely critical for working in our kind of environment. So. Do we test polyaspartic paint for wood as well? we take a look at all of our technologies and try to make sure that whichever formulation performs the best is what we are going to recommend that our customers will take and produce, and that end users will use. So if the best performing coating for a bridge is an aspartate, we would recommend that. If the best one for a wood coating is an aspartate, we would recommend that. But if it's a waterborne polyurethane dispersion, we would recommend that. So we recommend whatever technology that we can supply that will give the best performance in any given application. UV coating varnish formulations. So we do have a whole group, and that's actually not a laboratory that is here in Pittsburgh. We have a whole series of resins that are UV curable, and we didn't really talk about that, but UV curable means you put down that paint and then you hit it with a strong ultraviolet light, and it cures very, very quickly. Those things are used in applications where you really need to have a dry, finished surface as quickly as possible. We do have a whole series of those, and there's a lot of information available about our UV coating resins out on our website. Thank you for the question. What strategy do we recommend following to get strong coating on aluminum-based material surfaces? Anybody want to take that? My recommendation is in any coating system. There are two ways to do it. You can pick a coating system that itself has great adhesion. If it's very critical, then usually we would recommend a primer system, and that's a coating that goes underneath the outside coating, which has a main purpose of sticking well to the surface. So, there are different preparations and different primers that work well on plastic or steel or aluminum, and picking the right one is critical to the success of the overall coating formulation, or the coating system, I should say. I was going to say, Scott, you want to take this?
Yeah, so as John mentioned earlier, we do have a number of different technologies that are UV curable technologies. Oftentimes, a lot of them are free radical initiated. That means basically it's a material that's added to the coating, which when it's exposed to UV light, it forms these things called radicals, which then start the polymerization process. So I'd say most of the resins that we have are going to be radical induced polymerizations. There are some technologies that are cationic, especially we use that type of technology a lot when we're actually making some resins as well too. So making some of the materials, especially some of our acrylic chemistries as well. But oftentimes the coating formulations are often radical induced polymerizations for sure. So the next question.
For the students in our audience, we had another point come up, and in addition to that question about preparation and what kind of things that you might study before you come in, whether it be chemistry, whatever, we have programs here where we bring students in as they graduate, and we try to turn them into permanent employees by running them through a program. One of those is called our trainee program. We have internships over the summer, and then we have a rotational trainee program. Maybe Stephanie can tell us a little bit about what it is to be in that program and how that can lead to great jobs at Covestro.
Absolutely. So one thing I would recommend is if you're interested in getting into the industry, I would recommend looking for an internship. That's first and foremost. Really delving into these concepts, into testing, into working in resins. There's really no experience like it to really understand the market. And then having that be, a pathway into the trainee program. The trainee program is pretty unique. We actually have a rotational program where you get to experience all the different types of products across the Covestro portfolio, as well as the different paths to market, which can differ from product and sector to sector. So I think that's pretty unique. At least to Covestro, and also allows you to get a full overview before you're permanently placed. So I think that's really, it gives you a good wealth of contacts across the entire organization. And it really gives you a better understanding as to the value that Covestro offers. Now, I know I'm not the only trainee who's gone through that, so I'll give it to Daniel if he has anything to add here.
Thank you, Stephanie. I did go through the rotational program, and I also was an intern at the time, and so it was a very good opportunity for me. But I will mention, so a lot of our interns are usually coming from colleges or universities, but we also offer or we don't offer, sorry, but we do partner closely with the Bidwell Training Center out in Pittsburgh for our to train technicians for our labs. And so a lot of the times, there are a lot of people who end up with, graduating from high school and stuff like that, and then start attending this training program because they wanted to go into the lab technician role. And so those are also possible options as well.
Thanks, Daniel, and thanks, Stephanie. It's good to let people know exactly how those programs work. Do any of the internship or work-based learning experiences begin in high school? It's a very good question. In general, most of our internships would start when you've completed a sophomore year in college. There's good reasons for that because you need a lot of good basis, foundational knowledge before it's not only productive for you to be in a laboratory, but also before it's safe for you to be in a laboratory. So we really do focus on people who have passed their sophomore year, completed their sophomore year in college. We will do tours occasionally here to show what is available for high school students, but we don't normally hire anything at the high school level for any kind of internship or position here. No? Okay. Well, once again, as part of the Rethink Learning Days, I really appreciate all of the students and teachers and for your participation today. I hope that you found this to be a good and productive virtual experience that gave you a little idea of what would go on inside a real-world laboratory in a company based here in Pittsburgh. So thank you again. I hope it was a great experience. Feel free to reach out to Covestro if you have questions about what we do, what our products are doing in the world, what our initiatives are for innovation and sustainability. And thank you again. We're glad to be part of Pittsburgh and glad to be part of your event. Thanks again.
Stephanie Kane.
Is now exiting.